Let's first discuss about the properties of aluminium. Symbol of aluminium is Al. First letter capital and then small. Color of aluminium metal is silvery white. Its atomic number is 13. Atomic mass is 27. Valency of aluminium is 3. Its electronic configuration is 283. It lies in the periodic table in period 3 and group 13. The process of extraction of aluminium was given by Hall and Herold in 1885. It is extracted from its main ore called as bauxite. Chemical formula of bauxite is Al2O3.2H2O. Bauxite contains 60% of alumina along with some impurities like sand, ferric oxide, titanium oxide, etc. The concentration of aluminium ore is done with the help of Bayer's process. Firstly, we have to grind the finely divided ore. Then the volatile impurities should be removed. It should be heated up to a temperature of 140 to 150 degrees Celsius under pressure with caustic soda, that is NaOH, for 2 to 8 hours. When we will heat it with caustic soda, sodium metaaluminate will be formed. Bauxite dissolves in sodium aluminate because of its amphoteric nature, and the impurities will be left behind. These impurities are called as red mud. This contains ferric oxide, which give the color to the impurities. Then these impurities are removed by filtration. After that, the sodium metaaluminate is cooled by dissolving in water to 50 degrees Celsius, and precipitates of aluminium hydroxide will be formed. These precipitates are filtered, dried, and then heated at a temperature of 1000 degrees Celsius to get alumina. So aluminium hydroxide must be heated at a temperature of 1000 degrees Celsius and we will get the alumina. Aluminium oxide has great affinity for oxygen, so it is a stable compound. It cannot be reduced by simple reducing agents like carbon, carbon monoxide and hydrogen. Hence, electrolytic reduction is done for alumina. In earlier times, many difficulties were faced while obtaining aluminium from alumina. Reason being that electrolytic reduction can be done in molten state only, and alumina melts at a very high temperature of 2050 degrees Celsius. It's very difficult to acquire this much high temperature, and moreover, the aluminium vaporizes at this temperature and cannot be collected. But this difficulty was removed by Hall. He found a suitable solvent in another ore of aluminium, that is cryolite. If we added small amount of cryolite to the main ore, the fusion temperature can be decreased. So what he applied? He applied current to the molten mixture of alumina, that is 20% of alumina was taken, 60% of cryolite was taken, and 20% of calcium fluoride was taken. That calcium fluoride is also called as fluorspar. So at this temperature, the globules start appearing. These globules were of silvery colored and were shining also. So these globules were of aluminium. So in this way, the aluminium is obtained at a lower temperature of 950 degrees Celsius. Now aluminium, which was once considered as a costlier and rarer metal, by the discovery of Hall, it became cheap and can be used in every home by common people. So as a result, the new revolution came in the industry and aluminium became a cheap metal to be used by everyone. This credit goes to the Hall as he reduced the temperature of alumina ore from 2050 degrees Celsius to 950 degrees Celsius by adding another ore of aluminium, that is cryolite. What is the formula of cryolite? Na3Al F6. Learn this formula properly because many times this formula can be asked in the exam. Electrolytic reduction of fused alumina, we need a rectangular iron tank with sloping bottom. Sloping bottom is required so that the molten aluminium should be tapped, and the tank is lined with gas carbon. This lining of tank acts as cathode. The electrolyte taken in the tank is mixture of molten alumina, that is 20%, cryolite 60% and fluorspar 20%. Then powdered coke is also sprinkled over the surface of the electrolyte. Now why we have taken this much percentage? Cryolite is needed as 60% because cryolite is needed to lower the fusion temperature from 2050 to 950 degrees Celsius. Then it also increases the conductivity of the electrolyte because electrolyte is almost non-conductor. Then fluorspar acts as a solvent for electrolytic mixture. Powdered coke is sprinkled to reduce the heat loss by radiations and prevents the burning of anode. Anode are the graphite rods dipped into the electrolyte. These graphite rods are made up of carbon. When oxygen gas will be liberated at anode, it will react with carbon to form carbon dioxide. As a result, the burning of anodes will take place and we have to remove the anodes again and again. For that purpose, the powdered coke is sprinkled so that the burning of anode can be prevented. Now, we will take the temperature of 950 degrees Celsius for heating the electrolyte, and 5 to 6 volts of voltage should be provided to melt the electrolyte. When this temperature is provided, then cryolite, fluorspar and alumina will decompose to form positively and negatively charged ions. The positive ions present in the solution are sodium positive ions, calcium positive ions and aluminium positive ions, while the negative ions which are formed are fluoride negatives and oxygen negative ions. Now we will see which reactions will take place at cathode and anode. At cathode, the aluminium will be discharged because sodium and calcium both are highly reactive as compared to aluminium. So aluminium will gain the electrons and will be changed into aluminium and will be deposited at cathode. On the other hand, at anode, the graphite rods are present. So oxygen will be liberated because among the fluorine and oxygen, the oxygen will be discharged itself. This oxygen will lose the electrons and will change into oxygen gas. And this oxygen gas will react with the carbon of the anode to form carbon monoxide. This carbon monoxide further reacts with oxygen to form carbon dioxide. As a result, the anode should be replaced again and again. When the supply of alumina decreases, the voltage suddenly jumps 40 to 60 volts. We had started with 5 to 6 volts. But when the alumina decreases, the voltage jumps up. So from this we come to know that the amount of alumina has decreased and we have to add more alumina into the tank. If a bulb is attached to the apparatus, it will glow brightly. Then the fresh alumina is added, and by this process we will get 99.8% pure alumina. By electrolytic reduction of alumina, we get 99.8% pure aluminium. But still, if this aluminium is used for making electrical circuits or electrical wirings, then we need more refined aluminium. For that, electrolytic refining of aluminium is done. And this process of electrolytic refining was given by Hoops. So its name is Hoops process. The process uses an electrolytic cell which contains 3 layers of molten substances of different densities or different specific gravities. Molten impure aluminium forms the bottom layer. The bottom layer has carbon lining. The tank has the carbon lining which acts as anode. And pure molten aluminium will form the carbon electrodes will serve as cathode, and this is present at the top layer. Middle layers are consists of mixtures of fluorides of sodium, fluorides of barium and fluorides of aluminium. When the electric current is passed, aluminium from the middle layer will pass to the top layer because that top layer acts as cathode, and an equivalent amount of it shifts from lower layer to the middle one. Whatever aluminium is present in the middle layer, that will pass on to the top layer. Pure aluminium is tapped from the top and aluminium obtained is 99.9% pure. Now see what reactions will take place at cathode and anode. At anode, the aluminium will lose the electrons and will change into aluminium ions. And at cathode, these aluminium ions will gain the electrons and will change into pure aluminium. So at the anode, from the impurities, the ions are moving towards the cathode, and at the top, means at the cathode, we will get the pure aluminium metal.